I'm Sebastian, a Reco Fellow 2021. I'm going to show you in this presentation about the challenges for the new era of Colombian coffee culture. We are located in South America, in Colombia, and our home is the department of Caldas, which constitutes the Colombian Coffee Triangle, in the municipality of Manizales. At Vereda El Arenillo, we have our coffee plantation named La Celia Farm. Here, we cultivate and harvest Arabica coffee Castillo above an altitude in the range of 1850 and 1900 meters above sea level. Other parameters are the temperature, which oscillates between 15 and 25 degrees Celsius, and we have a total area of 9,000 meters square. Let me talk about us. We are the coupling of a second and third generation. As you can see from this picture, to the left, me, Sebastian, to the right, my dad, Germán. This pic is when I was just a child. And a newest pic I'm going to show you is this one. We were doing some fermentation experiments. And this is the last one, this time from our coffee farm. Germán is a coffee grower. He collects the knowledge from the tradition of coffee family, around 150 years of tradition collected in this point. And Sebastian, I have a bachelor degree in physics and a master of science. I am the person who is trying to innovate in this coffee topic. If you set those two branches, we obtain our coffee brand named Café Soca con Sabor a Finca. This is our coffee roaster brand. We have different topics in our brand, which includes innovations, which leads to industrial growth, social impact, and coffee quality. On the other side, the research that I'm going to talk to you later is the fermentation techniques, coffee bean drying, and sustainability. We concentrate our efforts to obtain a specialty coffee, but I think that this should be changed to specialty coffee growers, where there is a set of generational rewards, renewal, and terrific coffees that I would like to do someday. Our brand has been supported by Cooperativa de Coffeecultores Manizales, where we sell our coffee and do the roasting process. They promote social initiatives in the benefit of coffee growers. Well, I'm going to show you at this point the specialty coffee journey. I have separated in different phases because it's necessary to think the coffee as a whole. The first one biological, second selection, mechanical, chemical, and physical. Well, let's begin with biological, where the first one it's the plant nutrition. The fertilizers, the use of the nutrients to the plants is complicated, since you need precision to fit what exactly does your coffee plantation requires. We are using inorganic fertilizers for precision. Nevertheless, as you can see in this pic, we are incorporating pericarp and mesocarp to produce organic fertilizers using earthworms. It's forbidden the use of pesticides in our farm, mainly due to two reasons. The first one is that Arabica Castillo is a varietal resistant to rust, and the coffee berry borer can be controlled using good farm practices. Also, the bean affected is removed in the process. The reforestation plans is the transition to be sustainable, to obtain a sustainable coffee farms. Also, it will be increase our biodiversity in our farm, and I would like to have a very friendly farm. Well, why is this important? We have here an initial variable that I have called false microorganisms that I'm going to talk to you later. The second phase is the selection. It's needed to pick the coffee cherries at optimal state and should be do it manually. Why? Because we have here difficult topology, because the coffee is grown in mountains and it's required to obtain it into a maturity point. Well, but we have here a social problem because most of the coffee pickers are paid for the quantity, not for the quality. Our farm it's paying based on quality. So we have here a dignification for the labor of the coffee pickers, and this is great. The second one is the homogeneity of the coffee sample, that it's a important initial variable to the rest of the process. Coffee cherries requires to be at maturity point, an optimal maturity point, to obtain a traceability of your process, of your flavors, of your final flavors. And another important point is the microorganisms characterization. Coffee microorganisms should be isolated in order to be identified, because those are different for every farm's conditions and coffee varietal. And why is this important? Because it's required the use of good microorganisms for human health. So we can couple in this point the farm microorganisms with the coffee microorganisms. So I'm going to show you why is this important later. The third step is the mechanical, which is not mandatory because you can obtain natural coffees. This point is used to separate the vein from the pericarp and mesocarp. Nevertheless, food manufacturing equipment it's necessary to be designed and constructed with suitable materials in order to prevent heavy metals migrations which are present in traditional coffee machinery. Another important point is the machinery disinfectation, which is required after and before pulp removal, because there could grow fungus and usually the machinery is exposed to ambient conditions. Also, the hygiene is very important for the whole coffee process. Finally, the pericarp and mesocarp are discarded in this step. As I have showed, we are trying to reincorporate as an organic fertilizer. This point is complicated because in this point the coffee mass can be contaminated. Well, let's go to the chemical phase, the fermentation. Do you remember the extraction of microorganisms? Well, this is going to be very important. The first step is to have a disinfected cherries. Cherry disinfectation is a necessary step in order to do a suitable fermentation. This is done in order to reduce microorganisms population, and it is done through ozono or UV mechanisms. The second step in this process is the inoculation. Once you have disinfected the cherries, it's necessary to define a specific fermentation profile. At this point, it's important to have characterized youth microorganisms because you could obtain different profiles and combination between them. For example, you can obtain a lactic fermentation profile if you inoculate with lactic acid bacteria as Streptococcus, Enterococcus faecalis, Lactobacillus, Leuconostochmus enteroides, Lactobacillus fermentum, Bifidobacterium, among others, or alcoholic fermentation profile using alcoholic bacteria as Leuconostochmus enteroides, Sarcina ventriculis, Simonas mobilis, or coffee yeast with Saccharomyces cerevisiae, Pichia, and Candida tropicalis, among others. And finally, you can do it an acetic oxidation using acetic acid bacteria through Acetobacter aceti. And well, we have disinfection, inoculation, and where I am going to do this process? Well, in a bioreactor, because it's necessary to have a suitable medium to carry out those processes. Also, you can obtain variables which can help to control the system, as pH, TDS, cell count, pressure, and temperature. And it's amazing because you can obtain a fermentation curve, in this case pH versus time. So fermentation, it's good for help using a suitable microorganisms. We can use natural coffee microorganisms to obtain a specific fermentation profile. And finally, we have the physical phase, or bean drying, that has to be an optimal water activity to save the bean. Mainly, we have temperature-based methods to coffee drying. This has been proposed in order to use solar radiation to dehydrate the bean. Nevertheless, there are some systems which the temperature exceeds above 50 degrees Celsius, causing a sealing into the multi-layer structure, and the water remains in the interior of the bean, which may cause fungus activity and probably the development of toxins. Another method this is an innovation. It's the osmosis method. That could be a solution for optimum coffee drying, because the drying can be adjusted to external medium conditions in order to couple the coffee bean parameters and obtain a balanced drying. Also can be obtained a drying curve of grain water activity of humidity versus time, which can be coupled to fermentation curve, and the roasters can use this information to develop better coffee roasting profiles. The idea of this method is to generate a density gradient. We have here the initial parameters being water density and medium water density. So as I told you, the idea is to generate a density gradient between the coffee sample and the external medium, or in this case air. Therefore, the water molecules inside the coffee bean are going to migrate to the air. Once the air have reached their maximum relative humidity, it will remove and new dry air enters into the system until the grain obtain the activity water goal. You can repeat this process. So you can, here we have the bean water density, which is greater than the medium water density. This generates, I'm going to show you here, a force, a driving force, and until this medium reach the maximum relative humidity, you can change the air at this point, in, out, and I think that this method could be great to dry the coffee. Okay. Well, thanks for your time. Follow us on Instagram, and this is our web page. Bye bye.